This is Algebra 1, Term 5, Lesson 8, Rates and Areas. We'll begin in slides with rates in a town. Then we'll move to Desmos' classroom to do an activity about areas underneath a graphs of functions. And then we'll move on to our last task, which is a team task, a poster project about a GeoGebra journey. So let's begin with our slides. The first thing students will do is they will click on this link that says Desmos Graph, and they will explore this function that is describing the rate people are entering a town as a function of time and hours. When they get in here, they will notice there's some data, and there's the equation in vertex form, and then there's A, H, and K. And their goal is to create a function that will go through all the points that are plotted here, and these are actually from the table. It should be a perfect fit, so if these numbers aren't coming out nice, they need to keep playing until they do. And once they get them typed, they will go back to their slides and they will put a picture of their equation. They do need to type it out, E of X equals, and then put their A, H, and K. So on the next row, they can come down here and type E of X equals like this. And they will type the function and just replace the A, H, and K with the values they've already figured out above. Once they've done that, they can take a picture of it and they can put that onto this slide. So the only question they have to answer about their function, and they'll have the function in the graph here, is this: what is E of 8 and what does that reveal in this context? Okay, now they're going to do a similar task, but this time using a regression equation. So now we have the people leaving the town. It's the same town, but we have a totally different graph now. So here's the function for the people leaving the town. So they're going to type in y1 tilde, and if they don't remember what to type, I did put it at the top of their slide. So they're basically typing this into the graphing calculator, and it will produce a quadratic equation to go through these points. And then they do need to retype it because they have to type it with L of X at the beginning, and they're going to screen capture that equation and the graph of this function they've already got and put it on this slide. And then they're going to answer this question: what is L of 8 and what does it reveal in this context? And then finally, they're going to put the two together. So let's take the function E of X, which is the one they wrote first, and let's subtract the function L of X, and let's call it F of X, and then insert a graph and a screenshot of their equation for F of X. Now, their equations are in different forms. One's in vertex form, and the other is in standard form, so it's up to you whether you want them to spend any time simplifying this, but it might be an opportunity to practice, simplifying expressions that contain polynomials. So if they do simplify, they would need to square their binomial, use the distributive property, and combine like terms and do all that fun stuff. One way you could do that, if you choose to go that route, is to use math.new and have them do it there, and they could actually insert a screenshot of their work along with their graph and equation. But that's up to you if you want to go to that much trouble. So next we will go to our Desmos activity. So this is about rates and areas. You may have heard of accumulation before. This is actually a calculus concept, but don't worry, it's not in a calculus. They don't do any calculus in this assignment. They're just doing the algebra and a tiny bit of geometry to accomplish the same result. So they're going to explore rates and areas and units in a context, and they're going to discover how the area under a velocity function will represent a distance. So in the first screen, they're simply going to move a slider and talk about it. So this is a class discussion. Be sure you are pacing your students. You do not want them to move ahead. You want them to stay with you, and you also want to foster rich conversations. So how much distance will you walk in 1 hour? Call it out. See if you can get a team to answer that question. How much distance will you walk in 2 hours? You could even write them up on the board if you want, or have kids come up. Maybe have a team come up and volunteer to put these 4 answers up on the board and talk about how they could use this graph to determine that. And then if they haven't already said anything about the area of that rectangle, you might direct them there because the area of this rectangle does represent the distance that is being walked. Now they're taking the same rectangle and we're at exactly t is equal to 3. What does that reveal? And so which of these answers make sense in this context? And then finally, they're going to use those answers that they have for 1, 2, 3, 4 that they've already generated, and they're going to put them in this table, and then they're going to plot those points on this graph and then type an equation to fit the data here, and be sure to restrict the domain. They will see as they type, and let me show you what I mean. If I just type an X in here, it shows the line, so whatever they type in here is going to appear in the graph. It should connect their points if they've done it correctly. So it's kind of a self-checking equation here. Okay, now we're in a totally different scenario. We're not walking anymore. We're pouring water into a tank, and we're given a very simple piecewise equation, and they're asked to evaluate this function f of x at 4 and tell what it means in this context. The next step is to graph the piecewise equation. Again, be sure you're pacing your students throughout this task because each task is building, and then it's going to be the next task it'll show this and then build on some more. So you want to make sure they're staying with you and they're producing this piecewise equation. Of course, they can type these pieces individually into Desmos to get the graph, but we want them to be able to do this honestly without the calculator if possible. And then here is the graph, but we're being asked now about the area of a rectangle that is underneath part of the graph. So what is that area? What are the units that are being used for that area? So you may want to point out we've got minutes here. So that means this side is in minutes, and we have gallons per minute here. So if you multiply minutes by gallons per minute, that's like gallons over minutes, then you're just left with gallons. So inside here, you should have an area that represents the number of gallons in the tank. And then here, they're actually calculating out the number of gallons in the tank for each of these minutes. So it started with 20 gallons, and that is something that kids struggle with because they think, wait a minute, 0 to 20 is not in this graph. And you may have to keep reminding them, this graph is not g of x. This graph is f of x. We're looking for a whole different function here of g of x. F of x is the rate of change of the graph. It's not actually the graph of g of x. So we can't use the numbers in this graph to fill this table. We have to actually find the areas in the graph. So we can draw in a rectangle here. And we can get this area inside here. You could color it in or not. I usually color these in, but it looks pretty bad. My bad. Sorry about that. All right, but the width of this would be 1, and the height would be 2. So this area is 2. So that means it started with 20 gallons. Well, after 1 minute, 2 more gallons should be in there. So it's up to 22, and they would type that in. And then they will continue that process going left to right. So if you go from 1 to 2, how many more gallons should be added? We already know that answer because we know it's going to be 24. So this area right here gives them another 2. So we got a 2 here and a 2 here. Now do another area and so forth. They keep adding them on here. Be sure to read the teacher moves and sample responses if you need help getting these numbers. Once they're done creating their table, it should look like this, and they will simply plot the points that are in that table on this graph using the sketching tools, and then they will create equations for 2 parts because this is not one linear function, it's actually a piecewise function. So create an equation for each piece, and if they do it correctly, their equation should connect the dots. Be sure to restrict the domain. We don't want the function falling into the second quadrant. We do not want the function going past 6 minutes. Now we're back to the walking activity, but this time, instead of walking at a constant rate, what's happening? What is different? They will move this slider to move the boundary line on this graph over. You can scroll out to see more of this. But you could talk about this is a triangle. This is a trapezoid. Oh, but what's this red? What's going on now? You may notice that this triangle is falling into the negative distance. What is negative distance going to mean in this case? So talk about that. And then now let's go back and look at what if B was exactly 4? What does this area reveal in this context? Well, what if B is exactly 8? Let's look at each of these times. So we start at 0, we go to 4, but what about 2? Now, a common misconception is that our 2 will be equally spaced between 0 and 4 for that distance, but that's one you want to talk about as a class, because take a look what happens here. If I place this at 2, which is here, notice how much area that is compared to the area between the 2 and the 4. That area is pretty small. So they are not equally spaced, and that's a common, kids will just do it automatically because they're used to filling out linear data. This is not linear data. So if you're noticing kids doing that and just putting a 2 here because 2 is halfway between 0 and 4, ask them to show you that in the graph. Where are you seeing a 2 for that distance? What would be that area? And then for 6 and 8, what would be that area? So they need to calculate those areas, and they can use the graphs to do it, and then they will place those numbers into this table. Once they've got their table created, they will plot the points on the next screen, and then they will write an equation to fit the data. And what's cool is there's 3 options for this equation. They can put it in vertex form, which should be pretty easy to figure out. They could put it in factored form, also very easy to figure out, or they could put it in standard form. I'm not sure that's as easy to figure out, but any of the forms can be correct as long as they intersect all the data. And that concludes our rates and areas Desmos activity. The last thing we'll do is a team poster project. So let's head back to slides. So to do this project, students are going to use an app in GeoGebra. And so when they get to this screen, they will click on the link to open the graph. They're told in their slide that the X represents the hours, and you're also told that the domain goes from 8 a.m. until 5 p.m. So this -4 would correspond to 8 a.m. And if you think about it, noon would be 0 in this case, and then 5 p.m. And then they're moving this slider around. I'm not sure why this slider starts at -2, so they may have to figure out how to get all this together. But let's just say we started at 8 a.m. What would be the area under this graph from left to right? And what is special about the area that falls underneath the x-axis? What's going on with this area? So each of these little distinct pieces, they can chop it up into parts to find the total area, but they are looking for area under the graph, and that will help them figure out their distance. So the domain is 8 a.m. till 5 p.m. The y is the rate of change in miles per hour. So these are hours and miles per hour. Describe this journey in detail, and what is the total distance traveled? Explain your thinking. Now, for the poster project, I've given them extensive directions in their show notes. So I'm going to pull these up so you can see them. What are the intercepts of the graph? And explain what those mean in this context. All right, well, the intercepts of the graph would be anywhere it crosses the x-axis or the y-axis. So there's actually quite a few. At -4, 0 is 1, 0, 1, 1, 0, 3, 0, and that's it. So that was the last intercept. Now, they may think 5, 0 is an intercept, but you'll notice that's just the line. There's nothing there. So if you move this, you can see there's no point. So they don't have to do 5, 0. But they should be able to tell me what those values are and what they represent in the context. And remember, X is hours and Y is miles per hour. The next question is, over what interval of time is the traveler moving at a constant rate? So their knee-jerk reaction will be to say, well, they're always moving at a constant rate because the graph is linear everywhere. But that's not true because this is rate. So we want to know where it's a constant rate. So the constant function might come to mind. And there may be more than one interval. All right, then they're going to put a poster together with the team that includes the graph and answers all the questions. So they're going to need to go back to their slides. Let's look at this. The slide says to describe the journey in detail. So they need to know when they started, time-wise, when they ended, anything significant along the way. So those intercepts, what's going on. How is their rate different as they go along? So what's happening to the walker here as this is rising? What's happening as the graph is horizontal here? What's happening here as the graph is decreasing? And then this negative area underneath, what's happening there? And then so forth. So there's quite a bit of text here, and their sophistication at this point will not be great, and that's okay. So we're not expecting them to master these concepts in Algebra 1. Our main goal here is to give them opportunity to wrestle with these ideas. So even if they don't master everything, that's okay. This is a very advanced topic, but it's also a rich topic that gives them lots of opportunities to think about what this graph really means in this context. And then the last thing they're going to do here is give the total distance traveled and explain their thinking. So they will need to include some work that they're doing to show how they found that. Now, when they put their team poster together and they are finished and have displayed their poster for other teams to view, so what I did is I would give kids these giant poster grid paper and lots of colored markers, and this is a very lengthy task here. So I would say at least an hour, probably more than an hour, even 90 minutes. So I'm putting 2 to 3 days for this assignment for that reason. Kids need lots of time to put the poster together, get everything on it, and then have time at the end to go around and view the other team posters. So if you're doing this over 2 or 3 days, maybe have them finish the poster one day, maybe come back and tweak it at the beginning and put them up. So I would have them basically put them on the wall outside my classroom in the hallway, because I had a big wall right by my class where I put all these posters, and I would help them. I have my ladder and my little handy Scotch brand adhesive. I would have those things to help them put the posters up on the walls. And then each team would be given a pad of sticky notes. I would usually give them different colored pads so that I'd know who did what sticky notes. It was just for my purposes, but they would go to each of the other posters and they would put one sticky note on the poster that has at least one of these things on it. An observation, so something they thought was interesting that they observed that they want to mention or talk about. A question, maybe they don't understand what that team did or why they did a certain thing the way they did it. So ask a question. And then an affirmation. So something you really liked or enjoyed seeing, or were, something good, something positive. But it has to be mathematics. It can't just be you guys are great. It needs to be about the actual task. So once those sticky notes are on their posters, they've had a chance to go look at everybody's poster. They will take a picture of their completed poster, and yes, they did those with their Chromebooks, and it was always fun to watch how they did that, but they got good at it. They would take a picture, and they will insert a picture on the slide of their poster with all of the questions answered and their work and their descriptions. So that would be their final task. Now, I often would go around myself and take photographs of work and put them in my files so that just in case their photos didn't turn out that great, I would have a really solid image to look at when I'm going over their data to see how they did and make sure they understand the concepts. And that concludes our lesson on rates and areas. Y'all have a great day.